Hey YouTube, today I'm going to be putting in a whole house surge suppressor on my circuit breaker box. We have a lot of trouble with lightning strikes here and just general surges and brownouts and so forth. Now this surge suppressor won't help out with the brownouts or voltage variations or electrical noise. That takes a special device. But what it will do is it'll take any of the voltage spikes and run them right to the ground, right to the earth. So this is a box I have to add on beside the circuit breaker panel, and it has a surge suppressor in it. Now this won't deal with a direct lightning strike, but it will deal with most like indirect lightning strikes and other voltage surges. And there's connectors on here where you hook in line 1, line 2, ground, and neutral. Now I have to say this before you try to imitate me. If you do this at home, you could kill yourself. I'm not joking or exaggerating. The stuff underneath this panel will kill you if you're not careful. So I would advise you not to do it on your own. Get some advice. Now this video, if you have already have some skills, it'll tell you how to do it. But if you don't have any skills, just use this video for information on, so you know what to talk to the electrician about when the electrician comes and does it for you. So I've already loosened these screws. Let's take that out. And there's only two of them left. Thought I had this one loose enough to get out easily. So this is the circuit breaker panel. I've got 200 amp service here. Now normally, if you're smart, you will have flipped this breaker to the off position before you even open up this box. But I left it on so I could show you what's hot and what's not in here. So I've got my voltmeter set to 700 volts. The maximum we're going to see here is about 250. So you have wires coming in from outside. Those come from the meter. And these up here, even when you turn off the circuit breaker, these are always hot. You touch those and then touch a ground at the same time, you're going to die. So don't touch them. Down below here, once you turn this breaker off, these are all turned off. But right now they're all hot. So this is a 220 volt service. Actually it's about 250. Single phase. Now they call it single phase even though you have two 110 volt phases. So let me show you here. This is the neutral or the ground bar. I'll touch one of these here with a tester. It shows 124 volts. Now if I move over here and touch this one, that's 123, 124 volts. But if I touch both of them at the same time, you get 250 volts. Now the way that works is that each leg of this 220 volt service is out of phase with each other. So there are two different phases, and I can't really explain how that works, but it works out so when you combine the two you get 220 volts. So once again to the ground neutral bar. This is the wires I'm going to take loose. You can see they're hot right now. And this is a 220 amp circuit, not 220 amp, 220 volt circuit breaker. It's got 210 volt legs. So now I'm going to turn off the main breaker and we'll get started here. Alright, so everything turned off. You notice the fan noise went away. I'm down in the basement, and if it wasn't for the battery powered lights I'm using, it would be dark as a tomb down here. So now, just to make sure, if you listen closely in the background, you can hear my uninterruptible power supply complaining. Should have turned those off. Okay, so here's we still have hot here coming in, so you can still kill yourself here and here. This middle one is the neutral though, that's nothing. Here's the problem bar. These two spots right there are hot. Down here, it's not hot anymore. Here it's not hot. So it's safe to go. Alright, so I have to put this box on. I'll zoom in for that. But let's talk about right here first. This little black box, I paid an electrician, certified electrician, to come out and put this in. It's a surge suppressor. comes up through here and ties into the well circuit breaker. Now he seemed to think that was going to solve my problems. And it may have. It was a little bit more than 2 years before I started getting burned out well motors again. Or a little bit less than 2 years. Previous to that, I'd been getting 1 a year or even 2 a year burnout. So it's pretty simple. It's got 3 wires. 2 black wires go to each leg of your 220 volt circuit breaker. The white wire goes up to the grounding bar, neutral bar. In case you didn't know this already, then all your white wires and bare wires hook to that same bar. And I've got a big fat ground wire. This goes out to a stake outside, stake in the ground. And anyway, that's how it works. Okay, so you've got these 2 wires. Each of those black wires is supposed to hook into one of these 120 volt legs. And they come down through here on a strip. And they're set up so they alternate. So that even if when you put these circuit breakers in 1, 2, 3, 4, this is on like the right leg, this one's on the left leg, this is on the right, this is on the left. And when you have a 220 volt circuit breaker like this one, it ties into both legs. So you wouldn't necessarily have to tie into a 220 volt circuit breaker to have this surge suppressor work. You could do 2 110 volt ones, because when they're right next to each other like this, they're going to be in opposite legs. I chose the 220 because it has bigger wires coming into it. Let me set this down. And that would allow me to, see if I can get up, maybe I'll use this camera here. No, that's not focusing. Let's go over here. So this is the back of a dead circuit breaker. I just took this out for an example. Here's my 8 gauge wire that I'm putting in, and here's a 10 gauge wire that is just like the wire coming into the existing circuit breaker. And you can see I've got a flat bar in here that tightens down with a screw. Now if I put an 8 gauge on one side and a smaller wire on the other side, like a 14 or a 12, like some of these are in here, and try to clamp it down, then this one would be loose and slip out. Even with just this much difference, I had to really tighten that down to get it to make sure it was tight. So you make sure that that is good and tight. Test your wires to see if they come out. Alright, so the first thing I have to do is put a hole in here for this box. The box has knockouts in it, and the circuit breaker panel has knockouts in it, but the knockouts stop right here. There's some more down low, but I need to put it in right here. The reason you need to put it in around this neighborhood is because you want it, according to the directions, you want to have the surge suppressor as close to the input as possible. So if you put it down here, all these other circuit breakers are going to experience this surge before it gets to your surge suppressor. And to give it optimum chance of working, it has to be up at the top. And for some reason they want the wires to be as straight as possible with no sharp curves in them. And the directions, it says try to make your curves a nice gentle 4-inch curve, sort of like that. But you can see inside this box you're not going to be able to get any gentle curves. So I'm going to compromise and do what I have to in the box and then have it come straight out through here. One will tie in. I'm reluctant to touch anything in there with my bare hands even when it's turned off. Right here is an opened place on my neutral bar, and then the black and red wires will tie in here on my 220 amp. Alright, so it's going about like that. I'm going to use this knockout here. Alright, so the first thing I have to do is take this knockout out so I can run the wires through it. I thought about drilling it so I could have the hole in a better place. So just a sharp tap will take that out of there, break it off. So now this has got to go up here. And I've got some wires in the way, so I've got to use one of these gizmos. It's an offset coupler. So now this will go here, and I'll turn that to meet the hole where it needs to go. So I'm going to compromise a little bit between the neutral bar and here and have the hole be up here a little ways. It's like right about there. So I have a marker. I can mark where it needs to go. So that's where my hole goes. Now, you can see from this camera here, right, you can see from this camera that these wires could potentially be in the way, and I don't want to drill through those wires. So I have, they used to be all bunched up like this, but I've pushed them up out of the way. And when you do this, you want to be super careful that you do not nick any of those wires with your drill. So I have to pause this and get something else. Alright, I'm back. So I'll slide this piece of plywood in here. And that'll, I can, when it inevitably slips through, I'll hit the plywood before I hit any wires. So the first thing is a pilot hole. It's a brand new drill bit. Can't get leverage on it. Okay. Now I'll put my plywood back. Switch over to a step drill. So we're going to switch over to this. And this is pretty much the only way to drill sheet metal as far as I'm concerned. Any other drill bit's just going to cause you trouble. It'll catch and it'll bind. It'll auger all the way through. I hope this drill bit, or this drill, is up to this task. I've never drilled a hole this big with it before. Tell you what, the metal in this box is really hard. I didn't expect it to be so hard to drill through. Probably going to ruin my step drill. Decided to use a little cutting oil. A little tape would have helped. Alright, a little tape to hold the board in. nowhere near close enough yet. The size, that is. Okay, I'm not going to drill anything important. Alright, where's my gizmo? Oh, it's in the box. Nope. Gotta go a couple more hole sizes up. That is close. One more. Okay, I think I finally got it. Alright, I've got a hole. No damaged wires. Clean up my oil a little bit here. Now this is going to have a sharp burr on it, so be careful about that. Once again, don't kill yourself. It's a nut. Putting a nut on here. Okay, so now that I have this bolted in mostly, let me tighten it down a little bit. You can use your screwdriver to get it in the right neighborhood as far as tightness goes. And it's better to use a wrench after that. Come on, fingers. Alright, so that's tight enough for now. So now I've got to drill or fasten this in with screws. So the next step is to fasten this down with screws, this little box. Line it up. Let me put this on screw driving. Alright, we're fastened down. I'm done with my drill. And now, let's run some wire. So I have way too much wire here, but like I said, it's for another project. Oh wait, first thing I have to do is tighten down those nuts on the extension. We'll do it the old-fashioned way. Just hook onto it with a screwdriver and tap it home. Alright, snug. Now let's feed some water through. Start with the black. Don't have to use red. 2 blacks will work just fine, but I was buying wire anyway, so I thought I might as well buy red, make it look pretty. And white. Alright, can you still see me? Maybe I should zoom in a little bit here. Now, tie into this panel. Got a ground that goes back here. Have to get a wrench for that. And, let's see, if you have it upright, we've got neutral and ground at the top, and line 1, line 2 at the bottom. So this has got to go up at the top. And since this box sticks all the way down, almost touches the back of this, I can't go behind it. So I'm going to have this wire come around to the top side of it. So let me strip it. Don't need a whole lot of exposed wire on this. Now, if you're working on anywhere that it could possibly be hot, see, this isn't even connected to the box yet, so I'm safe. Do not use non-insulated tools like this. That's how I almost killed myself when I was in my 20s. So it's probably a good practice to never use non-insulated tools. This is where the neutral goes in. I've got to loosen that screw to make room for it. So I'll put my neutral wire in there. It's got to come in like so. So that'll be up there like that. Have to pull a wire in. Next, I've got to do the same thing for my line 1 and line 2. Let's strip those off. Alright, so those are in. Going to bend them around a little bit, work this back down in here. And remember to put on my ground. Once again, I've got to go get a wrench. So now I've got to put on the ground wire. Get that sucker back in there. And this little nut on it. Now, why did they feel like that had to be done on the inside? Why couldn't that be something you could attach to the outside of the box? Now, whatever box you put in here, it's got to be grounded to the main panel. I didn't check to see if the main panel is earthed or not. Let's double check that right now. Can't see that on either of them. Alright, so I'm going to ground it to the main panel here. We got voltage. So the main panel is earthed. Alright, so now it's a matter of working this in here. Oops, it's going to go up like that. There it is. Now to cut the wires. I'm not going to tighten this down yet. So let's do the neutral wire first. It's always a good practice. Cut off just a little bit extra. Strip it. My screwdriver. I have to put on my glasses so I can see what I'm doing. It's always twice or 10 times as hard to do these kind of jobs when you use large wires. Large wires are always better, in my opinion, especially when you're trying to do a surge suppressor. You want to have it as much capacity there as possible, even though the surge is just momentary. Alright, the neutral is secured. Tell you what, I'm going to fasten down this box here so it doesn't rattle around so much. Now, just to be symmetric, I'm going to put red to red and black to black. Take off a little extra. You can always cut it a little shorter if you have to, but you can't make it longer. Alright, so loosen up the clamp. I'm going to loosen that out all the way. See if we can get this puppy in there. Without peeling off any of the wires. Well, that's the other thing, is I got stranded wire. I'll talk about that in a second here. Crap. Alright, finally got that in. Let's clamp it down. Nice and snug. Make sure the existing wire is still snug. And we'll do the next one. Right to there. Stick it out to here. A little extra. Darn it, I keep reaching for the wrong tool. Loosen the clamp on the circuit breaker. Okay, so it's in. Now, let me make sure I've done everything correctly. We've got the ground, the box is grounded. It's grounded to the circuit breaker panel. Line 1 and line 2 coming in nice and straight. The neutral is run into the neutral bar. So I should be able to turn the circuit breaker back on now. Ideally, you put the cover back on first. This is a bitch to turn. There we go. Lights coming on. Furnace turning on. Let me turn off that fan. So, these two lights, as long as they're illuminated, that means it's not blown. And all I've got to do is put the cover on. Alright, let me tell you a couple things before I let you go. You can go anytime you want up. So this is stranded wire as opposed to solid. The stranded wire has several advantages. The main advantage is that a stranded wire will carry more electricity than a solid wire. Solid wire is cheaper. That's why everyone uses it. Another advantage to stranded wire is that it's more flexible. Makes it easier to work with. So here, let's put it over here where you can see it. See, this is not just one solid wire, it's a bunch of wires. I didn't count them, there's about a dozen of them there. And of course I cannot remember the name of the scientist that figured this out. He was the same guy that invented radio waves. He's an Italian. I'll put his name up here. But anyway, he did an experiment that proved that electricity flows on the outer surface of any conductor. So if you have a copper wire, the copper metal has an electron cloud around it, basically, and that's where all the current flows. It doesn't flow through the center. So if you've got a solid copper wire, like this one, if this is 8 gauge, the only place it's conducting electricity is on the outer surface. So if you have a multi-strand wire like this, each individual strand can conduct electricity on its outer surface, and that gives you a lot more surface area, so it can conduct more electricity safely. That's why I like stranded wire. Another thing you might want to do to prevent killing yourself is when you work on electrical projects like this, even if you think the thing is off, that's how I almost killed myself once because I thought it was off, and I was stripping wire with a non-insulated pair of pliers. You wear heavy boots that are non-conductive, have good thick rubber soles, so you're not going to get a ground through your feet. When you work on something like this, try to make sure only one hand has a possibility of touching a hot wire. If that's the case, then the worst you're going to do is, like if you touched a hot here and the case at the same time, you get a shot going from here. It would radiate up your arm some, but it wouldn't kill you. You may not be able to let go, but it's not going to kill you. Now if you have, for instance, if I'm touching the box, a good solid ground like this wire here, this BMX, with one hand, and I touch hot with the other, it's going to go through my heart. And you will not be able to let go. I know this from personal experience. You won't be able to breathe, you won't be able to scream, and it'll just kill you. The only reason I'm alive is I tripped this 30 amp circuit breaker. So anyway, be careful. Have an electrician do this unless you already know what you're doing. That's it. Goodbye.